Today we'll be doing basic geometry vocabulary. You'll be using the two foldables that I gave you out today in class. Hold on one second. The vocabulary is very important because if you don't understand the vocabulary and how to name things, other things will get mixed up. So make sure that these are some notes you really take your time on and practice on. The first thing we're going to go over is points. And so this is a point. And so write whatever I have printed on there, point. And this is an example, it's point A. As far as the definition of a point has no size, a point has no size, and it names a location. You know, like when people say to go from point A to point B, it names a location. To name a point, you're going to use a capital letter. So, for example, that on the top flap, you could either write it like this. You would write point A, or you would actually write it out, point A. The next one we're going to talk about is array, and you already have the picture of the array right there. The definition of array is that it's part of a line that extends at one endpoint and extends forever. Well, starts at one endpoint and extends forever in one direction. So on this last page, it started at this point A, and then it went forever in this direction, indicated by the arrow. Okay, the way you name a ray is you have to use the 2 points that are making up that ray, and you have to start at the end point and then through another point. Realize that it extends forever in one direction, so it really doesn't matter what other points you use as long as it's going through that arrow. But you need to start at whatever end point you want to. So, for example, our picture on the front, the way we would name that is we would use the ray symbol above it, and then we would put capital A and capital B. The next one we're going to talk about is a line. Notice that this is this is the wrong thing. Okay, this time, this one is a line. The other one was actually something else, and we're going to talk about it after a line, but it's still considered a line also. Once you understand the definition of each one, you'll understand what I mean by that. So this is a line. Okay, so a line has a straight path. So it shouldn't zigzag or anything like that. It has no thickness, and it extends forever in both directions. So I should add that, in both directions. Okay, the way to name a line is you either use a lowercase cursive letter or 2 points on a line. So on the previous picture, on the front flap, you see that it has a cursive L. So the way I can name that line that's on the front is I can say line L and be done. But if it does not have a cursive letter, then you need to use 2 points on that line, and you need to make sure you use the line symbol above it. So I could call it AB, or I could say BA. It would indicate the same line. Okay, next is opposite rays. Notice that it is a line. Opposite rays make a line, okay, but they are, the way you name them, make them opposite rays. The definition are 2 rays that have a common endpoint and form a line. They're going to go in opposite directions, okay, but they have the same exact endpoint. The way you would name it is the same way you would name a ray, okay, but you would name 2 of them because they're opposite rays. So on the flap on the front, notice that you have 2 rays that are meeting at the same endpoint and going in 2 separate directions. When you're naming them, they should have the first letter being the same. So I would have ray BA and ray BC. Our next word is plane. Not the plane you ride into different countries, okay? Just plane. The definition of plane is that it's a flat surface, no thickness, and extends forever in all directions. The way you name it is you either use a cursive capital letter. So for the picture on the front, we could say it like this. We could say plane M. or you use 3 points not in a line, okay? And if they're not in a line, and if you notice A, B, C on the front are not in a line, so I can say plane A, B, C, okay? I will not use the word not in a line later. I will tell you the definition of when the points are not in a line. The next one is endpoint. The endpoints are the things that the arrows are pointed at, so they're not the whole line and array over again. The endpoint is here and here, and this is also an endpoint. Okay, endpoints is a point at the end of a array or a segment. Like the picture showed you. I didn't tell you how to name it, so you don't have to write nothing on that side of the flap, because you name it the same way you would name a point, because it's an end point. The next one is a segment. A segment is the part of the line consisting of 2 points and all the points in between them. The way you would name a segment is by using the 2 endpoints. For the picture on the front, you would put the segment symbol above it, so it's just a bar. And you would write AB or BA. It's important you know how to name these things. The next one we will talk about is skew lines. Skew lines. Skew lines are are shown here. You see where this arrow is here for VU, for line VU and line PQ. Okay, those are examples of skew lines. The definition of skew lines are lines that do not intersect and are not parallel, and they do not lie on the same plane. So going back to the picture, notice that VU and PQ are not parallel to each other, and they are not on the same plane. Okay, VU is on this plane, on this side here, while PQ is on this plane down here, or this plane in the front, okay? There's no way different to name skew lines, so you don't have to put nothing on that flap, because skew lines, again, are lines, so the way you name a line is the same way you would name skew lines. Okay, collinear is the next one. Collinear. All the ones on this foldable, we will not talk about how to name them, okay? Because collinear are points, so I really should put collinear points. So collinear points, okay? Collinear points are points that do lie on the same line. Do is the key word in this one. They do lie on the same line, okay? So notice that points A, B, and C lie on the same line. So you would name collinear points the same way you would name a point. Non-collinear points are 3 or more points that do not lie on the same line. Again, they are points, so you would name them the same way you would name a point. The next one is coplanar points. Coplanar points are points that do lie on the same plane. Again, they are points, so since they are points, you would name them the same way you would name a point. Non-coplanar points is the next one. So notice on this picture that it is 2 planes intersecting each other. Okay, so non-coplanar points mean points that do not lie on the same plane. Okay, they do not lie on the same plane. Again, they are points, so you would name them the same way you would name a point. But for example, if you look at the picture on the front, point M, and point A would be non-coplanar. Point M, A, and X are non-coplanar. Even though A and X are on the same plane, M isn't, so that makes them all non-coplanar. Okay, so if you need an example, I would put example, A, M, and X, Y, X, and Z, not Y, X, and Z, Y, X, and M. Okay, M has to be part of it because it's the only one that's on a different plane. The next one is called a postulate. A postulate is a statement that is accepted to be true without proof. So it's usually the things that in geometry that make total sense without you having to really prove it to someone. That when they explain it to you, you're like, oh, yes, that makes sense. So I'm going to tell you a couple of postulates in a second. The next one is a theorem. A theorem is a statement. A theorem is a statement that has to be proven. And so usually, like Pythagorean theorem, they had to prove that a squared plus b squared equals c squared. Okay, the next one, I'm going to tell you two postulates. This is postulate 1-1-1. You don't have to really know the name of each postulate, but you do need to understand it. Alright, so this one says through any 2 points, there's exactly one line. It shouldn't have that one. Okay, remember, a postulate doesn't really have to be proven. So look, if I draw a point and another point, I can only go one way. I can only go to the other point. I can't make different paths to that same point. Okay, so through any 2 points, there's exactly one line. Our last one for our two foldables. We have postulate 1-1-2. Through any 3 non-collinear points, there's exactly one plane containing them. So remember the definition of a plane was, well, not the definition of a plane, but how to name it. You needed 3 points, not in a line, so 3 non-collinear points. So anytime you have 3 points, okay, there's a plane containing those 3 points. Okay. Tomorrow in class, we will glue these two down into our into our spiral, and I will answer any questions that you might need from me.